In this video, we're going to go over the flow control nodes. This video might be a little bit longer as we have to go over all of these nodes over here. I'll make sure to divide the video into chapters, so it'll be easy to keep track of where you are in the video. Let's start with the branch node. We're just going to use a keyboard event F as the trigger for this node. And the branch node is one that we've already discussed in previous videos, but just in case someone is coming here just for the flow control nodes, we're going to go over it again. If you're familiar with coding or programming, then you know about if statements. This is basically an if statement in Unreal. It's just called a branch. To get this node, you can right click, type in branch or if. You could also use a shortcut, which is B on the keyboard and then left click, which will bring up the branch. Let's connect these execution pins. Now it checks for a condition. If this is true, then this will happen. Let's say is true, false. So what I've done is just created two print strings when it goes to true and when it goes to false. Let's create a variable. Down here by the variables, you just click on plus and we'll call it is true question mark. And then we're going to have to get a way to set this variable. So we're going to say set variable and we're going to create another keyboard event. Let's use Q. Whenever Q is pressed, it will set is true to true. So, and here we can get true and it will get the result. If the variable is true, it will print is true. If it's false, it will go to false. Compile and save. And when we play our game, let's press F and it says is false because that's the default value of the boolean. Now, if we hit Q, it will change it to true. And then we hit F again and it will print is true. Now, one really cool thing about blueprints that I haven't showed you yet is you run your game and you make the window a bit smaller, you move it aside. Here on the top, you can select a debug object. So we're going to select BP third person character and we're going to get back to our game. Now, if we run this game and we trigger any of these nodes, let's say we hit F, you can see in the blueprint what the flow of execution is. So this makes it very easy to debug. Now let's hit Q, see that it activates, and now we hit F, it'll go to true. You'll see the execution line goes up. So that's it for the branch node. Let's move on to the sequence node. Let's break this line by holding Alt and clicking on that line. And we'll connect that F key node to the sequence node. What the sequence node does is it executes both of these executables in order from top to bottom. So let's do a print string, executed 0, because this is execution pin 0. Here a print string that says executed 1. Compile and save. Now if we hit F, you'll see it will execute both. It will first go to the top one and then go to the bottom one. Even though it seems like it's simultaneous, it is important to note that if you have two different things executing, but you need this one to execute before this one in order for this one to work, you do need to make sure that these are in the right order. You can also add more pins here, so it executes even more. Now if we hit F, all three will execute. I often use the sequence node when I have a trigger that I can only have once in the blueprint. For example, an event tick, you can only add one event tick. If I try to add it again, it will just point me back to the one I already have. So sometimes that's quite annoying. If you have multiple things working on that one execution, it'll just become very unreadable. What I like to do is I add it to a sequence, and then I can have one function here, another function there. Let's get rid of this so that I can separate the two. So it'll be a lot more readable. So that's it for the sequence node. Let's move on to the do once node. Let's connect the F here and we'll say, we're just going to use print strings on all of this. What the do once node does, it's self-explanatory. It just allows you to do something once until you trigger this reset pin. So let's take this Q over here that we used previously and connect that over here. So F will execute, print hello. Now if you press F again, it won't work until we hit Q because that resets it and you can do it once more. Now let's try it. F, hello, and it only lets me do it once. You can see F is executing, but then at the do once node, it stops and you see the flow of execution stops there. Let's hit Q, resets, and now if I hit F, it should work again, but only once. That's it for the do once node. Next up is the do n. The do n is very similar to the do once node, but instead of once, you can set it to another number. So connect the F, connect the Q to reset, and print string again, straighten that out. And right now it says 0 here. Let's make it 3. You can either just write that in there, or if you need it to be equal to a certain variable, let's say you have an integer variable, we can get it, connect it, and now it will be whatever this integer's value is. So we can set it to 3, and now it will run 3 times. So F, hello, hello, hello. Now it won't work anymore until I hit Q, and then I can do it 3 more times. So you could either plug in a variable or just type in a number here. And that's it for the do n node. The flip-flop node is very simple. Let's connect the F key event. We'll add 2 print strings here. The flip-flop node will execute A first, then B. Then it'll go back to A, B, etc. A, B, A, B, A, B. Very straightforward. Next, let's look at the gate node. Gate, or you can hold G and left click. That also creates a gate node. We enter the gate by pressing Q. We open the gate by pressing F, and we close the gate by pressing E. And exit is just a print string that says hello. And then there's the start closed pin. You can check this or uncheck this. Basically it means when the game starts, is the gate open or is it closed? Compile and save, and then you'll see what it does in the game. So if I press Q, you go to the gate, but the gate is closed, so it can't run whatever is on the exit execution pin. But if we press F, that means we open the gate, and now if we hit Q, it'll print hello each time. Then if I press E, which closes the gate, it won't work anymore. Now another thing we could do is instead of having 2 separate keys for opening and closing, let's use Alt and disconnect this one. An easy trick to move these lines around is if you hold Control, you can click and drag it like this. So let's go to toggle, compile and save. So if we hit Q, it is closed. If we hit F once, it opens and it runs. Then if we hit F again, it closes and it won't run anymore. So each time you hit F, it'll toggle between open and closed. That's it for the gate node. Next, we have the MultiGate. So let's connect the Q. You have 3 execution outputs. So we'll add 3 different print strings. And we'll print A, B, and C. So compile and save. Now if we hit Q, it'll print A, then B, and then C. It will go from output 0 to output 1 to output 2. But once you've done all 3, the gate closes. If we connect F to reset, that will reset the multi-gate. So if we hit Q, 0, 1, 2, and then it closes. If we hit F, it'll reopen the gate and we can start from 0 again. If we check the box here at loop, then the gate won't close. So we will just go from 0, 1 to 2, and then it goes back to 0, 1, 2, and it'll just keep repeating itself. And if we check the random box, it will randomly execute one of the 3 nodes each time. So it will go, now it's printing 0, then 2, 1, 2, 0. Now note that it will never do 0, 0, 0, 1, for example. It'll take the 3 execution pins, execute them in a random order, and then restart from 0. It'll execute those 3 pins again in another random order. If we uncheck is random, it also has a start index. So you could, for example, say start at 2. In programming and coding, you often start counting at 0. That's why it starts with output 0, output 1, output 2. This 2 is actually the 3rd execution output. So that's output 2. So now if we run it, hit Q, it'll start at 2, go to 0, go to 1. Next up is the for loop. We'll just connect the Q and we'll do a print string and the body. So everything that comes after the execution pin here it will loop for whatever numbers you have set here. So index 0 is the number that it starts counting. So first index is where it starts counting. Last index is where it stops counting. So let's do 0 to 9. So that's 10 times. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 times. So that means that when we press Q, it will loop this body 10 times. Let's compile and save. So it prints hello 10 times. Now the for each loop. The for each loop is very similar, but instead of you giving it numbers, you give it an array. I'll make another video about arrays. An array is basically a list of variables. So let's create a variable and we'll just keep the name at new var. We'll get the variable. If we drag out of this output pin, we can say make array and add some pins on the left. And just copy and paste this one. So we'll add these ones. You could also add different ones. Just for now, to keep it simple, we'll just add these 4. So this array, we'll attach it over here. And for each item in this array, it will execute this pin. So it should execute 4 times. So as you can see, it prints hello 4 times. Just to give a quick example, we created this cube earlier in the game. So let's say that we have this cube multiple times in the game, and we have 5 of them. We can make a list of all those cubes in the game, an array. That array will have an index of 5, so it'll run the code 5 times. For each cube, it will run the code 5 times. And then we have the while loop. The while loop will loop the body, which we will connect here, so it'll print hello while a certain condition is true. So let's say we have our new var here that we created earlier. We'll just put it in there. And we'll say while var is less than 5, this body should be running. What we created now is an infinite loop, and this won't work because this variable is 0, and nowhere in this function are we adding to that. It will always be less than 5, so it'll continuously loop, and that's not good. It won't work. What we have to do in the body of the loop, we have to increase this variable. Get this variable here, and then add, and then set new var. We can either just use an addition node here, where we can add whatever we want. But if you want to just increase by 1, you can also press the plus key twice, and it'll say increment float. So every time that this runs, it'll just go up by 1. So this will work. So this will, when we hit Q, while new var is less than 5, it will run. And when it runs, it increases it by 1. So that means that it should run 5 times. But let's add a print string so we can see it running. Then when we hit Q, oh, this is actually an infinite loop because we forgot to, so it says here infinite loop detected. We forgot to connect this pin. So every time that it ran, it set the value of new var to 0 each time. We forgot to add this one in here. So now it will increment by 1 each time. Oh, and also I'm noticing we have 2 print strings. So let's get rid of this one. We'll just move that back over here. And now it should run 5 times with no problem. There we go. So that's it for the flow control nodes. I'll see you in the next video.